So we're going to talk about asymptotes, and I know that that's something that you have done before, but if I just take, for example, just as a quick review, let's say we take the graph of y equals x squared. Now you did this in your summer assignment, and I know you've done this last year as well. So it's just a sketch. It's not the best thing in the world. But the point that I'm trying to make here is if you notice this piece of the graph, as it gets closer and closer to the y-axis, it's never going to touch it. It will get closer and closer to the y-axis, but it will never intersect it. That's called an asymptote. So the y-axis is an asymptote, as well as on this part of the graph as well. Okay, now the x-axis is also an asymptote because the graph gets closer and closer to the x-axis, but it will never touch it. So what we're going to be doing is just looking for, in this case, a vertical asymptote. So if you look up here at the box, and this is on page 2 in your packet, it says to find the vertical asymptotes of a rational function, simply set the denominator equal to 0 and solve for x. So if we look here at this function and it asks us to find any vertical asymptote or asymptotes, we simply look at this denominator, and all we're going to do is we are going to set it equal to 0 and we're going to solve. So we know then that we have a vertical asymptote at x equals -5. Now, all vertical asymptotes are going to be in the form of x equals. And let me just show you on this graph over here at the right. A vertical asymptote would be a line that goes vertically. And whether I draw it there on the y-axis or here, you can see that the equation of any of these green lines is going to be x equals and then some number. Okay, so make sure that your vertical asymptotes are always an x equals. So now I'm at the bottom of page 3 in your notes, and you can read through the notes at the top of page 3 if you so choose. Those are just more examples, but I'm going to get right to it, and I would like to look at these 5 examples, and it's just asking us to find the vertical asymptotes. So again, remember, simply set the denominator equal to 0 and solve. So our vertical asymptote for number 1 would be x equals -4. All right, so now in number 2, we have a little bit more work to do, not too much, but we know that we have to set the denominator equal to 0, but we're going to have to factor that. So if I factor that, that should be x minus 6, and that should be x plus 1. When I solve, I'm going to get x equals 6, and I'm going to get x equals -1. So those are my 2 vertical asymptotes for that particular question. All right, number 3, denominator equal to 0. I know that I have then x equals 0 would be the vertical asymptote. All right, so for number 4, I am going to set that equal to 0, and I am going to factor out a 5x. So that would give me x minus 2. All right, now just remember that when I have, and I'm just going to rewrite this, 5x and x minus 2, and I set these values equal to 0, just please remember that when 5x equals 0, 5x equals 0, that really means then I have an x value of 0. So there's one of my vertical asymptotes, and the other one is x equals 2. Okay, last one, number 5, set that equal to 0. So off to the right over here, I'm going to factor that, and that's going to be x plus 4 and x plus 3. We're going to set that equal to 0, and I will end up with 2 vertical asymptotes, one at x equals -4, and the other one at x equals oops, it's supposed to be a negative, right? Let's make that look like a big equal sign, and there's your negative. Okay? Okay, now you can read through page 4, and I am basically toward the bottom half of page 4 here. So what it does say is when the polynomials are the same degree, if we're talking about horizontal asymptotes, we just simply reduce. So I'll explain what I mean by that. So if I look here, horizontal asymptote, guys, we've been doing this. Essentially what you're going to do is you're going to do end behavior. So you can take the highest power in the top and the bottom, okay, and you're just going to reduce that. And that is going to give you 4. So horizontal asymptotes, remember we've spoken about this. I like to do end behavior, and I would probably write that in your notes. So now let's look at a graph. Any horizontal asymptote, and let's go back to that y equals x squared that I had drawn before. So our horizontal asymptote in this particular case is the x-axis, which would have the equation y equals 0. So whenever I have a horizontal asymptote, my line's going to be drawn left to right, horizontally. And that's always going to be a y equals. So up here, when we have 4 as our answer, what we were doing prior to this was we were not saying, okay, find the horizontal asymptote of this function. We were taking the limit of this function. Okay, so the only difference that we're going to have here is when we want to write the horizontal asymptote, we're going to write it as an equation. So horizontal asymptotes are always going to be y equals, and in this case, it's going to be y equals 4. All right, so vertical asymptotes are x equals, horizontal asymptotes are y equals. And again, we're doing end behavior, and since the top power and the bottom power are the same, those cancel out, and your answer is just that number, just like when we did limits. Now I'm on the top of page 5, number 2, all the way up at the top there. And I just want to show you another one. So again, horizontal asymptote, just like we've been doing when it came to limits, we're just doing end behavior. So we're going to look at the highest power in the numerator and highest power in the denominator. All right, so when I do that, I end up getting, and I end up reducing, I end up getting x. So remember I told you, when you don't get a number, then what you're going to do is you're just going to draw a picture of that function. And there's, a very bad line, but there's the equation, the graph y equals x. So remember when we were doing these kinds of questions, it was always in reference to the limit as x approaches infinity. So we're going to think along the same lines. So as we go to infinity, do you see this value goes to infinity? Okay. All right, so I'm going to just go backwards for a second. So when we had the limit of this function, and I'm going to, when I say f of x, I'm referring to this one, as x approaches infinity, we would then say that the answer is infinity, because as this graph, which is y equals x, goes toward infinity, our y value gets higher. So that's what we said our answer was, right? All right, well, listen, this question's a little bit different. It's not asking, hey, what's the limit of the function as x approaches infinity? It's asking, what is the horizontal asymptote? So our horizontal asymptote, we can't say y equals infinity because infinity just keeps going and going and going. So here's the long story short on this. Okay, when we end up getting a function and we do our end behavior and we end up with, let's say, an x here or a 2x or a 1/2 x, as you go toward infinity, if your picture is going toward infinity, there is no horizontal asymptote because we don't have y equals infinity. So we would just say none. No horizontal asymptote. Okay? Now, if you read in the notes what it says, and it's totally true if you want to look at it this way, when you have a higher power in the numerator than you have in the denominator, there will be no horizontal asymptote. If you prefer that, go with that. I'll repeat it one more time. If your exponent in the numerator is higher than your exponent in the denominator, you will have no horizontal asymptote. I prefer to look at it as, well, wait a minute. If I look at this function and I look at the limit as it goes toward infinity. If it goes to infinity, I don't have a horizontal asymptote. Okay, take your pick. All right, let's look at the third one. So I am going to do the same thing, end behavior, and that ends up being 1 over 2x squared. All right, well, I'm going to draw that picture, and I know an x squared looks like this. And as I'm going toward infinity, just like what we were doing before with limits, do you see this is going towards 0? So that means my horizontal asymptote will be y equals 0. Remember, horizontal asymptote always has to be a y equals, and we can have it going towards 0, just never infinity. That's the only exception, so to speak. Now, on the bottom of page 5, you'll see those 5 practice problems, so that's where I am. They're asking for the horizontal asymptotes, so I'm just going to go ahead and I'm going to do end behavior, highest power on the top and the bottom. I'm going to reduce that, and that ends up being 5x. Okay, this is the one that I was talking about. 5x looks like this. As I go toward infinity, that is going toward infinity. Can't have that. So there will be no horizontal asymptote. All right, I'll repeat one more time. As your picture goes toward infinity, if your y value keeps going toward infinity, no horizontal asymptote. All right, let's get the next one. This is a nice easy one because the x's cancel out, so then I know my horizontal asymptote is just simply y equals 7. Next one, number 3. Oh, we got lucky twice, huh? Those x squareds are going to cancel out. That's 3 halves. So then I know that my horizontal asymptote is y equals 3 halves. Remember, horizontal asymptotes, again, always y equals. Okay, so let's look at this one. All right, not so lucky, but we can still do this. That's going to reduce to 2 over 3, and we're going to have an x in the bottom. So now let's look at that picture. So that picture, I'm going to squeeze it in right here, is like that, right? Okay, horizontal asymptotes, always look at them as x approaches infinity, like a limit as x approaches infinity. And watch what happens. As we go toward infinity, this goes towards 0. So that's totally fine. We can have that. So our horizontal asymptote would be y equals 0. Now let me go back a second. So let me just stop here. Remember I said to you before, if the exponent in the numerator is higher than the exponent in the denominator, we have no horizontal asymptote. So down here we have the opposite, number 4. We actually have the higher exponent in the denominator. If that happens, your horizontal asymptote is always going to go towards 0. Okay, so if you prefer that, go with that. All right, let's look at the last one, number 5. We got lucky again. Those x squareds cancel out. That ends up being 2. So our horizontal asymptote is at y equals 2. Alrighty, so I'm on the bottom of page 8, and I'm going to start by looking at numbers 1 and 2. Now this one wants us to find all of the asymptotes. So I'm going to start with horizontal. So now notice that I have the higher power in the denominator. So that should be a y equals 0. Now I'll show you that just in case you want to do that the other way, which I like to do it the other way, but you don't have to go along with me. So when I take that and I reduce that, that is 1 over x, right? And I know 1 over x looks like this. And then all I'm doing is I'm looking at this picture as x goes toward infinity, and notice it's getting lower. So that means it's approaching 0. All right, vertical asymptotes. Now vertical asymptotes are always x equals, and we always take the denominator and we simply set it equal to 0. So in this case, I'm going to factor that to x plus 1 and x plus 1. And then I'm just going to solve that. So I know that I have x equals negative 1. So x equals negative 1, and that would be my vertical asymptote. All right, number 2. So this is 1 over x to the 4th. Well, you can take this from 2 different perspectives. the higher power is in the denominator. So then we know that the horizontal asymptote would be y equals 0. Now, we haven't done graphs of 1 over x to the fourth, but by the way, they do look very similar to 1 over x squared, even powers. And again, so then a limit as x goes toward infinity, that approaches 0. Okay, and that is a 0, by the way. That's not a 6. 0. All right, now vertical asymptotes, we set the denominator equal to 0. So I'm going to factor out an x cubed there, and I'm going to get x squared minus 4. We're going to be setting that equal to 0. So I've got dots, so x cubed, then I've got x minus 2, x plus 2. So you can see actually I have 3 vertical asymptotes here. That's fun. So I have x equals 0, I have x equals 2, and I have x equals negative 2. There's all your asymptotes for 1 and 2. Now, number 3. End behavior, I see that that reduces to 5x, right? And I know 5x looks like this, and I know then as the limit of that function as it approaches infinity goes toward infinity, so then that just means that I do not have a horizontal asymptote. The other way you can look at it is the higher power is in the numerator, and if that's the case, there's not going to be a horizontal asymptote. Okay, vertical asymptote. Oh, well, this one's easy, right? X equals 2. Set the denominator equal to 0. There we go. Okay, last one on page 8. So we can look at this again from 2 perspectives. We notice here that we've got the higher power in the denominator, which means that that limit will approach 0. Okay, or if you don't like it that way, the way I do it is that reduces to 1 over x. I know the graph looks like this, and a horizontal asymptote is always as x approaches infinity, and you see that that y value is decreasing, so going towards 0. All right, vertical asymptotes. We're going to set the denominator equal to 0. I'm going to factor out an x. I get x minus 1, and then I end up with x equals 0 here and x equals 1 here. So my vertical asymptotes are x equals 0 and x equals 1. Oh, but wait, Miss Carter is wrong on number 4. So here we go. Now, I would like to say that I actually made that mistake on purpose, but I actually didn't. But I'm really glad I made that mistake not on purpose, because everybody does what I just did on number 4. And I shouldn't say everybody, but a lot of people do. Okay, so if you look at the top of page 8, it starts talking about holes. And sometimes functions do contain holes. So this is what I want to kind of drill into you, and we're going to continue doing this again tomorrow, is that when we're looking for horizontal and vertical asymptotes, we also have to sometimes look for holes. All the other questions that I've done so far in this video are correct. I didn't make any mistakes. But this one I did. So this is what I want to tell you, is when we're trying to find horizontal and vertical asymptotes, I'm always going to tell you, listen, step 1, always look for, and you may want to write this down, and it is at the top of page 8, but I don't know if, it's written in a way that you would be able to understand. I think it is, but you're always going to look for horizontal asymptotes first. Always look for those. So I was not wrong when I started with number 4, when I said that the horizontal asymptote is at y equals 0. That is true. Okay, the second thing then we're always going to look for is we're going to look for holes. Oops, make that look. Okay, holes. So, and then I'm going to write cancel them, and I'll explain what I mean by this. Okay, and then after that, the last thing that you're going to look for or vertical asymptotes. All right, so let me go back to the beginning here. So let's pretend as if we were doing this, and it, from the beginning, and it was saying to find your horizontal and your vertical asymptote. So I'm still correct in this. Highest power, numerator, denominator, reduce. That's 1 over x. I look at that picture as I'm going toward infinity. I know that that approaches 0. So my horizontal asymptote is y equals 0. No difference there. All right. Here we go. So this is the mistake that I made. So when you want to find vertical asymptotes, you actually have to look for holes first. So if I look at this function f of x, right, and I say, well, that's x over x squared minus x, do you happen to notice, which I did not at first, that these all have a factor of x? So what I'm actually going to do is I am going to just leave the numerator temporarily. And I'm going to factor out the denominator because there's a GCF. So that would be x minus 1, right? Okay, this was the part that I didn't do. These are common factors and we can cancel them out, right? This is where you have holes in your graph. So guys, you do not have a graphing calculator. You have to do this in your head, and they didn't give you a picture. But if I were to draw a picture of this, I'm going to have a hole in the graph here at x equals 0. Okay, because this would reduce. Or if I were to set each of these equal to 0, you would have x equals 0. So let me just do this. So here is my hole. I need to cancel out those holes. And the reason why I need to do that is when I'm now looking for step 3, vertical asymptote, this cannot count as a vertical asymptote because it got canceled out because it was considered a hole in the graph. Okay, so now when I'm looking for the vertical asymptote, you see, I hope, why I was wrong before. My vertical asymptote is simply just going to be at x equals 1. So I have a vertical asymptote at x equals 1, and I have my horizontal asymptote. Let me just say this is my vertical asymptote, and my horizontal asymptote was at y equals 0. So just to repeat one last time, you can always do your end behavior first. After you do that, factor if it's possible, and then look for your vertical asymptote after you have canceled out your common factor, which is really technically considered your hole.